Pascal? You were talking about trusted sensors for a greener world, I think? Perfect. And let us know when you're ready to start.
So next slide, please. This talk is about trusted sensor, and sensor and network sensor are widely used to monitor environmental safety. So it's a major topic for scientists, public, and political communities. You have some example of organization like Product Track in Paris that monitors the pollution, TVRA, which is about radiation, and EPA in the US for manufacturers. So basically, a trusted sensor is a sensor with tamper-resistant resources. It should be low cost, very trusted, and for that, based on open technology. And the benefit is trust for collected measures. So next slide, please. So the idea is that you could organize sensor around secure elements, including named, that you say, TLS server with name, server name, providing mutual authentication and secure communication. And so when you talk about trust in payment, you have a EMV bank card or electronic passports, and all that is a shift thanks to secure elements that you have in your pocket, like SIM card or bank card. So you should have internal command for administration, exported command for actuator sensors interactions, and on-demand cryptographic resource authorization. So next slide, please. So this is the first illustration. You have some TCP/IP resources, and you have a secure element which run TLS named server. And so for TCP/IP over TLS, for some network interface, for example, in GitHub, it's a simple, it's a shell. It's like it's a command, ASCII command, ending by carrier return and knifing command. And you can send some command to the secure element in order to initialize key and do some administration stuff. And this is described in a draft called the TLS SE for TLS secure element. And you have other stuff in another draft, which is called Internet of Secure Element, which introduce other stuff in order to download software in secure elements through TLS. So next slide, please. So exported command means you receive a command over TLS to the secure element, but in this command you have some prefix, and we use a sharp character, for example, and this means the secure element will export in clear form this message, and this command will be executed by sensor actuator, which will return a message in a clear form that will be encoded again by the TLS stack. So next slide, please. And on-demand cryptographic resources authorization means you receive a command that is exported to the sensor actuators, like in the next previous features. But now the sensor requests to the secure element some cryptographic resources, for example, signatures, and then he returns a message in a clear form, which is again encrypted by the secure element. So next slide, please. So on YouTube, you have a video that shows you this. So you have a Wi-Fi interface, you have the TLS secure element, and you have a microcontroller. And what you will see, because many of you understand trace, you will see what happened in clear form and encrypted form. And what does this small device? That it measures temperature and generates on-demand blockchain transaction. So next slide, please. So what's the goal of this presentation? It's to have some collaboration with people interested. There are many things to do, to define frameworks, to define network interface, and to define the guidelines. And I'm ready.
Thank you.